launching now.
Good morning, good afternoon, and welcome to this BTG webinar on lifecycle management, or the importance of keeping your instruments up to speed. Today, this webinar will be facilitated by Florent Bougerolles, the BTG Head of Lifecycle Management. And as usual, at the end of the session, we will be taking your questions. So please make sure that you type them on the right part of your screen during the entire event. That being said, let me wish a warm welcome to Florent.
Thank you, Estelle. And thank you and welcome to everybody for participating to this BTG webinar. My name is Florent Bougerolles. I'm Head of Lifecycle Management at BTG for Europe. And we have crafted for you a very special webinar today about the consistency paradox. And we'll see how the maintenance plays a major role for the performance and sustainability in pulp and paper industry. And maybe it's not obvious, but maintenance is an obsession for Patrick Michel, who is a gentleman on the screen now. He's a friend of mine and a casual practitioner of marathon, and he's specialized in the long run that can be from 75 to 100 kilometers and over. And his next challenge will be in June in Iceland, and because he planned to run 1,400 kilometers in 17 days, meaning that he will be performing 80 kilometers per day. And he does that for collecting funds for supporting the research against the multiple sclerosis. And you can trust that he spent an immense amount of time in preparation, because his target is to ensure that he has a potential to run such a long distance. But ultimately, what counts the most is how he will be managing the run until the finish line, how he's handling the nutrition and the hydration during the run, so that he's maintaining the energy levels and is preventing the fatigue. It's also depending on how much he's adjusting the pace of running, the speed of running, depending on the weather conditions, depending on the terrain, depending on his body as well. Always planning the recovery and the rest, so that he's reducing the stress on the body and preventing the injuries. And also you can see on his wrist, he had a big watch, which is standard now for most runners, that help him to monitor his body, his heart rate, his temperature, so that he's listening to his body and he can anticipate the problems and decide to stop and hydrate. Patrick used to say that endurance runners don't train for the distance. They train for everything that will happen over that distance. So his preparation, again, is to make sure that he has a potential to make it. But the maintenance during the run ensure that he will perform it, he will reach the line. And his philosophy of running echoes very well with the pulp and paper process control parameters like consistency. Higher performance for longest time is a goal, and it depends on instrument choice, installation points, but also a lot about the maintenance. And again, the maintenance will ensure that you benefit and use the full potential of your instruments. And to further develop on this today, we have some very special speakers and experts in the name of Matt, who is a service manager in North America. We get also Suresh, that is country manager in India and in the South Asia region, and myself. And through this webinar, we will explore how consistency instrument and measurement maintenance contribute to process excellence by securing optimum consistency accuracy and repeatability over the time. And this webinar will take us over 3 parts. The first part will be about the history of maintenance, the practical benefits of maintenance, and we'll be also looking at some specific surprising practices into the pulp and paper industry. We'll see in the second part by Suresh how consistency performance drop over the time and what are the related hidden losses. And the third part from Matt will be about the solution range from BTG, how to put the consistency under control in a sustainable way. And the initial reason why we create this webinar is that we see more and more a gap between the ambition and the efforts. There is a massive investment in digital solutions, in newer technology, in software, in autonomous machine, there is big sustainability and energy savings project. And at the same time, there is a progressive disinvestment in the pulp and paper fundamental, such as process control instrumentation and its maintenance. And these fundamentals are not under control anymore, and this puts the whole process at risk. And the risk is taking the shape of a massive financial loss. And we've estimated that in average, daily per machine, the wrong consistency can lead to the loss of 2 pallets of premium toilet paper, or an equivalent of 3 pallets of corrugated carton board, or to 2 softwood pulp bales. And this represents respectively 120,000 kilo euros per year, 250,000 euros per year for board, and 400,000 euros per year for pulp. And if we translate this into sustainability KPIs, the wrong consistency leads to an additional release of 1 ton of CO2 and an overconsumption of 53 cubic meters of water per ton of paper produced per day per process line. This is just gigantic. And the major reason is that the maintenance of consistency instrument is often neglected. I'm quoting here an American professor of science and the maintainer, which is a think tank in Washington, DC. As it stands today, maintenance is not prioritized or recognized. We have an obsession for innovation and we disregard the mundane. And the message here that we tend to overlook at maintenance, whereas it contributes since decades to the development of the industry. And in the early 20th century, maintenance started very actively with a practice which we call reactive maintenance, that as soon as we get an issue on the machine, then we fix it and we continue to run. But soon the development of the economy and the need for the industry to produce more and more pushed the equipment to their limits, resulting into frequent failure and downtime. And this pushed the industry to think for a different approach for making sure that they were maintaining their operation in a healthy way. And this is where we've seen the development of the preventive maintenance. And the principle of the preventive maintenance is to have a routine work on the instrument, on the equipment, before the failure occurs. And this practice of preventive maintenance boosted during the Second World War mostly. There was a huge economic stress, there were limited resources, and then the industry was forced to better take care of the installation and equipment. And the routine maintenance developed a lot to keep the equipment in top operating order. And we can mention the example of the famous chip release. Because of the cost of the material, the difficult logistic at that time, and the time pressure as well, a routine maintenance was a must-have. And you can see as an example the maintenance manual for this car, detailing really all the check that needs to be done on a daily basis, on a weekly basis, on a monthly basis. Later on in this story, in the 60s, as the mechanism becomes more complex, the machine becomes more complex, and there were also a lot of big serious plane crash accidents. There was a need to think about another way of making maintenance to avoid these big difficulties and fatal situations. And this is where the predictive maintenance was deployed. So we were not only taking into account the operating, we were taking now more into consideration the operating condition on the machine or on the element to better anticipate the issues. So it was not only a time-based or preventive maintenance to avoid the problem was occurring. We're also looking at the conditions, the working conditions to make sure that we predict when the issue was occurring, and then we put the right action in place. And if we look today at the practice of maintenance, we have the following share, typically into the industry. We get roughly 40 to 60% in reactive, 30 to 50% in preventive, and 10 to 15% in predictive. If we compare that now to what is best in class into the industry today, we see that the reactive maintenance at a much lower proportion because they are using much more preventive maintenance and predictive maintenance. And the reason is very simple. There's using more predictive and preventive maintenance help to get a much higher machine reliability and also quality. It's improved the performance and reduce the downtime. And this is giving an advantage of the market. And we can make now a parallel with the tissue industry, where we are comparing the low performers and the high performers. And the study shows that the higher performers are much more maintenance job plan and schedule. And this is correlating very much with higher reliability, meaning better quality and better machine availability. Naturally, more maintenance and more scheduled work involve more cost. But in fact, the maintenance cost per quality ton is lower, meaning a greater performance and also a higher quality of the paper. And if you look on the internet and other literatures, there is a lot of studies which are reporting some benefit moving to preventive and predictive maintenance, because it helps improving the performance by 10 to 15% or even higher, decrease downtime and failure rate by 45%. And it's all great benefits. Now, if we're comparing the best in class or the typical industry maintenance with what we see for process control instrumentation like consistency measurement, we see that the reactive maintenance is still largely dominant. And if you remember the history of maintenance, this ratio here we see it for process control instrumentation, let's say 60-70 for reactive and 30-40 for preventive, is very similar to what we've seen after the Second World War at the time of the chip release. So in summary, for consistency transmitters, we are 75 years late in maintenance practices compared to best in class. And the question is why we underestimate maintenance for process control instrumentation. And our opinion is that there is a misunderstanding about process control instrumentation operation and its failure. I guess that the normal thinking that as soon as you get a measurement out of the sensor, it's working, it's good. But in fact, it's not really only this, it's much more complex than that. And to give you more detail about this, I invite Suresh.
Thank you, Florent. Hello, everyone. In this session, we will discuss about the consequences, challenges, and impacts due to the failures. These inline process instruments, when in running, needs care, and if neglected, leads to breakdown. Consistency indeed is an important and critical process parameter. As we all aware, pulp and paper process equipment's throughput is based on consistency and flow being the desired target. Next slide, please. We will discuss about the failure type to this important parameter. Failure will lead to measurement inaccuracy and may not be visible immediately. Failure will make the measurement move from being accurate and precise to inaccurate and imprecise. Precise and accurate consistency in any process application and unit operation will deliver stable unit operation, correct resource mix, for example, fiber ratio, chemical ratio, etc. Expect results to the quality and production target with optimum and affordable cost. On the flip side, if the measurement is inaccurate, the same leads to unstable machine runnability, sheet breaks induce downtime, off-spec papers, rejects and quality compensation, reduce process efficiency, and thereby productivity. When we usually hear failure, we visualize an equipment falling apart, shutting down completely with no power anymore. But failure can be in different forms. It can be a mechanical failure, or it can be an electronic or electrical failure, or due to any process or calibration disturbances. Let's see some mechanical failures first. As these instruments involve some moving parts, wear parts like sealings, drive belts, etc. When these parts gets weared and contaminated, leading to complete breakdown or measurement inaccuracy. Secondly, it can be an electronic or electrical failure, like issues like overheating of hardware sensor cards, making the measurements to freeze, motor tripping, power and signal cable issues, etc. In some cases, due to the process change in the fiber mix, ratio grade adjustments, the disturbance could happen. Also, after the repair or overhauling the consistency transmitter, it needs to be ensured proper calibration. Please remember all contact type sensors are shear force based and hence mechanically need to be stable. These type of failure we often do not consider but can have much higher impact on process performance than a mechanical failure. Because the measurement inaccuracy and variability may exist for weeks or even months before being recognized, inducing variability to the process and hidden losses. As per survey conducted by a popular industry magazine, majority of the unplanned downtime emergency maintenance of the equipment failures are coming from aging of equipments, lack of maintenance, and operator's error. The first one leads the major one. Next slide, please. And if we further drill down, when a sensor is not adding value to the process, the operator decides to switch from auto to manually, permanently disabling the measurement usage and failure. All processes, instruments, machine elements are subject to failure and follow a very similar pattern. After being started up properly, with time and to the given process conditions, a natural change in performance will happen due to the aging wear, etc. Equipment on machine is wearing out naturally and its performance shrinking progressively before it reaches its saturated end of life failure point. And this is exactly what happens to a consistency transmitter. In the beginning, the equipment is set up correctly, measurement is available, accurate and precise. But lack of attention because of no or low sealing water, scaling, contamination and wear will change its performance, causing big impact on fiber consumption, chemical addition, process stability, and sometimes causing paper breaks, etc. And this needs to be addressed with a new learned practice and competence, and most importantly, need to understand the instrument health condition, which then can lead to address a solution for maintaining the instrument the way it needs to be. Especially when these critical measurements are involved in a regulatory and advanced process control, which perform the chemical flow control or the feed forward to the QCS basis weight valve control. In these cases, our objective is to optimize the process and reduce variability, which cannot be achieved in a consistent way if the field instruments are not accurate, maintained and updated timely. We see the cause of poor performance of any equipment as per survey conducted by the popular industry magazine is aging is the majority of the contribution, lack of training the second most, lack of resources and lack of budget follows the same. Next slide, please. We shall estimate the cost of failure by applying a known methodology for risk cost assessment we come across based on our experienced service experts. In a case of a single consistency transmitter controlling a 20,000 tons of pulp per year in a corrugated medium without maintenance or calibration will lead to an estimated loss up to 18,000 euro of risk per year if we do not care. In this case study, we see based on the probability and consequence of failure in each category, the mechanical part is high. Rather, we could have prevented with minimum preventive cost, and similarly others also if we attend to it timely. Thanks to the reliability of instruments, some failures may not occur before years, but a single failure can lead to the stop of complete pulp mill, incurring millions of euro loss. The methodology involves here first the production cost risk, which is the effect of the probability of the failure coupled with likelihood of consequences and the cost of consequences. Let's see the probability of failure here. For each instrument, different failure types have been identified. For each of them, we define the risk and failure occurrence. Likelihood of consequences is a certain type of process consequence will happen once a failure type occurs. For instance, here if a sealing wear might induce a failure and complete mechanical failure after 6 to 7 years. With consistency accuracy impacted already started to get disturbed in 3 to 4 years time. So the cost of consequences is the evaluation of cost based on the type of process we're dealing with. Very similarly, this economics can be estimated for every mill to assess the impact due to the failure of critical measurements. Next slide, please. Now, if we see the impact across the unit operation, say in an OCC stock preparation, where there are several dilution stages, we shall estimate the total losses from different stages of dilution, considering how critical each stage for process performance. For sure, sensor after the pulper has less impact on process than the machine just sensor. But here, if you see the diagram, the relevance of sensor disturbance might represent only 20% of the consistency transmitter, and we often observe there is a lot more external factors influencing the consistency control apart from sensor alone, which are the sampling point and the type of sampler used, dilution valve process dynamics and its tuning, dilution capacity ensuring constant pressure, DCS control and loop tuning. All these elements may induce variation or lack of reactivity in the measured and controlled consistency value, leading to high process variability. With our audit program FiberMax, we shall assess the condition of all consistency loop, and benchmarking shall be done to further evaluate the performance improvement. My colleague Matt will talk about this later today. Based on our audit experience, only 40% of the control loops are healthy and the remaining 60% of the loop needs attention. This calls for the reliability solution with this lifecycle management program, and we support our customers with our subject matter expertise to increase the performance and shelf life of the installed transmitters by identifying the root cause of the performance issues. Next slide, please. We experience autonomous machine as we see in our digitization era. Advanced process control is already successfully implemented in pulping and paper manufacturing process, and we have our solution program like on efficiency in pulping, real-time solution for tissue, on efficiency in paper machine, which delivers enormous value to our customers. And these programs are scaled out to various unit operation to optimize the process in real time. The technique consists in collecting multiple variables which influences the key parameters to improve, optimize, and control the root parameter to ensure the key parameter is always on top. But if one of the root parameters like consistency measurement is constantly out of control with big problem of accuracy and precision because of failures, regulatory and advanced controls will never be delivering the maximum performance and will never be reliable. And we see now more and more digital teams deploying APC solutions in their process, coming back to fix the consistency control first, as they realize this is the mandatory step to success. But it is also the best practice to ensure and follow a schedule to monitor the signal from consistency transmitter, whether it is accurate and precise to deliver the performance as it was started up. This is why simple procedures like calibration check and preventive maintenance is imperative, which will help to attain sustainable results. BTG can help with the consistency care services. Not maintaining the instrument properly with or without APC will have a severe impact on process performance, and even small variations can lead up to big losses. And I would like to share here a few examples. We are talking about big money. In a fiber line where bleaching chemicals are dosed typically on a mass flow basis, any variation in the incoming consistency impacts the bleach chemical dosage, which then directly translates to chemical concentration in the bleaching tower reaction kinetics and thereby the bleaching efficiency and chemical cost, coupled with variability to the final target brightness, causing quality variation to the end product. Second example, in the stock preparation, in other process area of refining, maintaining the target consistency is critical for treating the fiber in such a way that you maximize the fibrillation and minimize the fines generation and cutting. At a plus or minus 0.3% change in fiber consistency inlet can create a 10% change to the fiber development, which directly impacts sheet strength properties and also disturb the paper quality with a change to the formation and fiber bonding, etc. In case of recycled, the damage will be even more, as in the form of fines generation, adding runnability issues. Another example is the blending fiber mix. While paper makers run the machine as per their predetermined recipes, if an inappropriate consistency transmitter is used even in one of the streams, the resulting blend will not be able to hit the target sheet specifications. For instance, an inaccurate consistency measurement on a broke line can cause sheet quality issues if not correctly used and will end up in runnability issues and poor quality if overused and creating more broke to circulate back into the system. I believe we now have a good understanding. If a consistency in the process is not accurate and precise, the consequences and failure to maintain will have a huge economic impact to the unit operation. With these sharings, I will hand over the presentation to Mr. Matt, my colleague from the US, to elaborate on the lifecycle management solutions and the tools we can support with the expertise available to achieve this lifecycle management program in a sustainable way. Over to you, Matt.
Hello, everyone. We have seen today maintenance practices corresponding to what we used in the 50s. and it's resulting in massive hidden losses when the instrument fails for various reasons, as Suresh pointed out. With the advent of technical evolution and increased software's capabilities such as AI, we are now going one step further with process control within the paper industry and seriously considering autonomous pulp and paper processes in the coming years. This is not fiction anymore. But from a single control loop to the factory of the future, it is critical that the inputs being used for control purposes are accurate, repeatable, and reliable. Consistency measurement is one of the critical inputs throughout the pulp and paper industry. As my colleague Suresh pointed out earlier, that the cost of failure is quite high. Proper maintenance and planning of instruments, especially consistency transmitters, are the key to accurate, reliable, and repeatable inputs for all levels of process control. In addition, there's also an increased emphasis placed on sustainability and environmental protection throughout the pulp and paper industry within the recent years. Customers are demanding that we be good stewards to the environment through their purchases. Customers are not just looking at the price of a product, but they're also looking at things like recycled content to make their buying decisions. And here again, maintenance of consistency instruments plays a great role to ensure that the right amount of fiber is used, that we're not over-consuming energy as in refining, not using too much water or chemicals, and we're not exposing our people to more risk due to unexpected failures. Maintenance is so critical for sustainability is that we are seeing terms like sustainability maintenance, and the pulp and paper manufacturers are recognizing that maintenance of their assets as a major pillar for their sustainability strategies. Next slide, please. So the challenges. Improvement will come from change in the approach, moving from reactive to preventive and to predictive maintenance. How do we do this? Think of change from a reactive to a preventative maintenance program as a journey. As with Patrick Michel's 1,400-kilometer journey around Iceland, it starts with the first step. For consistency measurements, that first step is to know where you're at, know the status of your sensors, understanding the loops and their performance. During the journey, or at least the start, there are many challenges that we have to overcome. For consistency measurements, it's always the same questions, is how can I be best in class with older instrumentation? Or I do not have the money to buy new transmitters. One thing to consider is what are the advantages and disadvantages of a new transmitter that is not well maintained versus an older, well-maintained unit. Let's take a look at a hot topic in terms of environmental stewardship, electric vehicles. Sometimes a solution seems counterintuitive. Electric vehicles have become the poster child for saving the environment and growing in popularity. However, some research shows that simply keeping our old car and maintaining it longer has less of an impact on the environment than transitioning to an electric vehicle. There are literally hundreds of articles of the environmental impact of gas versus electric powered vehicles. The more reputable sources say that overall, the electric vehicles are better for the environment, but it's not as cut and dry as you think. If you use carbon emissions as the standard, it takes between 4 to 7 years for electrical vehicle ownership to become carbon neutral over a well-maintained, highly efficient gas-powered vehicle in North America. What you need to consider in determining how soon you get to carbon neutral is that the generation of carbon emissions when the vehicle is manufactured, plus the carbon emissions generated with the battery. And then in addition, like in my area of North America, the Midwest, is that the cost of electricity to charge that electric vehicle is rather high. Is that because, and has a carbon footprint itself, is because we use mainly fossil fuels. The same spirit can be applied to the pulp and paper industry. It is valuable to sector and the environment to secure our existing assets and maintain them as long as possible for improving performance of the processes and to have a positive impact on sustainability. A good life cycle management of your existing equipment or instruments, such as consistency transmitters, is key to the improving the processes and having an impact on sustainability. So back to our journey. To take that first step, it is to know where the status of your instruments, the loops, the tunes, the sample valves, etc., in what we at BTG called FiberMax. FiberMax is a holistic approach to consistency measurement in the paper making process. Everything relies on fiber mass flow. Pulp mix, refining, chemical addition, basis weight, all rely on stable, accurate, repeatable consistency measurement. Each consistency control loop is part of a chain that is designed to take out variation before key unit operations. Unfortunately, not all control loops are always healthy. As Suresh pointed out, is that doing an audit, is that we find that roughly 30 to 40% of the control loops are not healthy. The BTG's FiberMax review finds the weak links hidden in the chain and outlines the proper steps to bring these controls back to health. So what is FiberMax? FiberMax is an intense check of the entire unit operation, instrument installation, maintenance practices, the health. We perform bump tests along the way to check out valve response for the dilution valves, set point and consistency variation, consistency reduction and control, dilution design and capabilities, and then control loop performance. In addition, is that we look at a benchmarking study as well. Is we determine where you are in terms of what we consider best in class. We identify those gaps and the benefits to improving the situations. So the outcome of the FiberMax survey is we make proposed solutions and recommendations, estimate the best investments on those solutions and recommendations, and give you an idea what it takes in terms of investment to achieve those estimated benefits. Taking the next step in the journey, we begin working on the solutions and recommendation, and that typically starts with the weakest link. And some of the tools that we use to look at that weakest link are CalCheck, which is a physical inspection of the transmitter itself to detect any type of anomaly. We check the calibration consistency in the lab and compare with the measurement itself. We also take a look at how you measure in the lab as well, in seeing if you're properly measuring the consistency. And if calibration is required, we'll make recommendations in terms of that. In terms of loop optimization, is that checking the P&ID settings, the dilution valve reaction, evaluate the impact on the consistency variation and stabilization. So what we do is turn an inaccurate and not reliable consistency measurement into best of class. What is the next step in the journey to preventative maintenance? In predictive plan, that is maintaining our gains. Specifically for consistency transmitters, how do we guarantee that the value the output remains accurate and precise year after year? The solution, preventative maintenance, structured in a 5-class system at BTG. Every good maintenance starts by periodic inspection and housekeeping made by the user every week or every month to ensure an early detection and avoid issues with the instrumentation. Simple but useful and highly effective. There's nothing like going out and doing a physical inspection while on site. On a regular basis, calibration should be verified, eventually adjusted with an offset until a new calibration can be added. To avoid failure and repair, preventative actions from class 3 and 4 should be scheduled based on process situation experience to maintain instruments in instrument measurement quality, then avoiding loss of performance that we have seen before. So next slide, please. Ensuring reliability of consistency control also means investing in the right instruments and considering the long-term benefits rather than just going with the lowest cost investment. We need to look at the total cost of ownership. So let's compare usage of disposable and cheap with high quality instruments. Over its lifetime, it will lose the low cost option will lose accuracy and induce variability in the process, generating additional costs that are often hidden. After a few years, you might need to change it because it cannot be repaired anymore. A higher quality product will maintain accuracy longer, and proper maintenance plan will help ensure that it is maintained at top performance. And after a few years, there might be a need to change the disposable instrument because it cannot be repaired. Then after a few years, the story repeats. For a higher quality instrument, which was well kept and maintained, efficiency and performance remained at a good level, and in total, helping make significant savings. So the total cost of ownership is actually 30% less than what you have with the cheap disposable transmitter. We have plenty of examples like that around in our personal environment, in our cars and in construction. For me personally, is that I'm a woodworker, and then I have a compound miter saw. And for years I had a cheap compound miter saw that I used. And I bought the saw because it was on sale and I was brand loyal. I said, I maintained that saw, but after many years of what I thought was reliable service, I finally had to replace it. It wore out. And then I treated myself to more expensive, higher quality tool. And what a difference did that make? I said, it made a tremendous improvement in cut quality, minimizing waste and time savings. Is that what I didn't realize with that poor quality instrument or saw is that I was having to make fine tunes and adjustments, and that some of the cuts that I had that were so off that I had to actually throw it out and then restart again. So I was wasting material. With the new saw that I have, I set it up, it runs, it makes accurate cuts, and it maintains its reliability over a period of time. And what I've learned is that can be applied into the pulp and paper industry. And then continuing on our journey, the next step is to take advantage of the evolving technology and move towards predictive maintenance. Performance of instruments highly depends on process conditions like pulp type, kappa, proper lubrication, etc. An example, MEK running without any seal water for a few days results in premature wear of seals, then create leaks that may generate damages, and then eventually it'll fail. We have issues with pipe vibration or overheating of electronics. I do a lot of work in the southern part of the United States where the temperatures read into the hundreds degrees with high humidity, and a lot of the transmitters are outside exposed to the elements. To help preventative failure of these instruments, now exists remote monitoring capabilities. This is a check that all internal operations parameters on the sensors are okay, and that there are no premature issues. Just like Patrick Michel's smartwatch that monitors his vital signs and alerts him if there's any issues that he needs to stop and rest or recover or rehydrate while he's doing his run, we can also use that technology to monitor the health of our instruments. As data analyzed by a service engineer remotely supported by the data management software to identify the anomalies within there. And next slide. I said monthly follow-ups and checks of if the instrument is working in the proper control limits. So when detection is when detection is triggered, when the alarm is triggered, an action can be coordinated with the customer. It might be a check or a maintenance check. This will anticipate fatal failure or a big deviation to minimize losses. Now we have early detection failure, measurement quality drift, and maintenance warnings are some of the things that we have with remote monitoring capabilities. Now we're into our journey from reactive maintenance to best in class. To make the remaining journey go smoothly, we not stray off our path by sticking to our plan. For consistency measurements, it's a life cycle management program. Paramount solution in life cycle management is a long-term program combining maintenance services, performance service, instrument monitoring, and engineered scheduling. Building a plan to define service visits to maximize the install base is consistency care. Each instrument having a different maintenance routine. Several visits per year for instrument check, maintenance, and calibrations updates are required. Smart monitoring for all of the consistency transmitters will help also anticipate needed visits for maintenance. We may get a warning and we'll schedule the visit to come in to take a look at that warning to understand what is going on. Continuous care of the installation base. One of the things that we call reliability assurance agreements is a consistency care program. The purpose of the RAA is to guarantee optimum performance of the instrument so that it's providing a reliable, repeatable signal for use and control purposes. And the benefits that we we prevent costly surprise and unnecessary downtime. And expanding the long-term consideration planning of the major maintenance operation is to go into upgrade and replacement. Some instruments require complete overhauls every few years. This can be done at our service site or at the mill level. Some instruments, because of lack of key spare parts, and because there's too much damage or wear, have to be replaced. Planning major operations help design a controlled budget for long-term vision, is that you control your costs over a longer period of time, but you're not taking a major hit on the capital budget due to a unexpected failure. As with Michelle's journey around Iceland, our life cycle management journey is a marathon and not a sprint. We at BTG are here to help support you along your way. And now I turn it over back to Florent.
Thank you, Matt. All what was described before and BTG Lifecycle mission is to provide the solutions to contribute to pulp and paper process performance, help on the cost reduction, help on the process and quality stability, and also on sustainability. And the solution we design are very much aligned with the principle described into Ellen MacArthur butterfly diagram, which is here to promote the circular economy and the sustainability. And again, the maintenance has a much larger potential than most industries are aware of as a main contributor to industrial ecosystem. And again, the solution we propose to our customers are here to help maintaining and prolonging the life of the instrument so that they are delivering constant and high quality measurement, that it can be used to reduce the fiber consumption, to make sure that the machine is running smooth, and so on and so on. And we have different strategies. We can collaborate very closely with the customer to perform the maintenance. We can provide some spare parts. We can help making some repair at the service center. We can do some service also on site, and sometimes the customer can do the service themselves. There is different stage and different of services that can be done, as was explained before, with a different class of services, class 1, 2, 3. Customer has a role to play in this maintenance things. We also have some various strategy to reuse, redistribute, or remanufacture some parts. There are some online analyzers that stay at the customer site, where we are taking the old part of the analyzer that we are refurbishing at the service center, so that we also minimizing the exchange or the usage of new piece. Again, we are trying to minimize the stress on the environment with these things, and this is less traveling and less time on site as well. So we are working on reducing our impact for unnecessary travel and unnecessary replacement of new parts. And naturally, this is a standard approach. Now we are recycling. We are taking back all instruments and we're recycling in the proper way. So I'm sure that you've heard about the butterfly effect. It's when the small flap of the wings of the butterfly can create disasters million kilometers away. And that's the same with consistency. A tiny failure or tiny deviation of the measurement can cause a severe impact on the process performance and sustainability. And there might be different sources for that. We've seen all the sources along this webinar. They can be mechanical, they can be related to the electronics, and most of them are related to calibration drift, because the process change, because the fiber mix change, because the type of fiber change, because the production capacity of the machine change, and we should pay attention to make sure that this is under control. And we can put that in the control with BTG Lifecycle Management Solutions. And often we are building the solution with the customer. Not every customer needs the same things. Not every instrument needs the same routine of maintenance. Again, it depends very much on the process. It depends very much on the way the instruments are used and for which purpose. And this needs to be worked, designed, and adjusted with the customer process and expectations. And the benefit of all of this is that naturally we are preventing the costly failure, we're reducing total cost of operation, we're improving the number of the quantity and the quality of the good tons, and naturally also improving the safety of the people. And after all, we are contributing to the sustainability. Thank you very much for your attention. I think that now we can move to the questions.
Yeah, thank you, Florent. Thank you, Suresh, and thank you, Matt, for all your insights on the lifecycle management. I hope our entire audience enjoyed the session. It is now indeed the time for questions. So if there is anything which is still unclear, where you would like to know from our experts their thought, if you have some specific challenges, this is definitely the moment to ask your questions. And we will make sure that we take them during this session and follow up with you after the webinar. So let's start with the first question, which will go now to Suresh. Suresh, the question is the following. Could you help us understanding how you calculate the cost of failure of an instrument?
Thank you, Estelle. Yes, as it was explained in the presentation, we have a very high experienced service expertise, which calculates this with the help of a methodology called the probability and frequency of consequences and the cost of each type of failures. So we will address this first to understand how this failure of instruments is occurring first. And then we take the consideration of your process, like if you're having a pulp mill or having a tissue machine, or if you're having a packaging board machine. So we will calculate those process parameters also taken into account. And then we have the cost also involved here to see that the failure occurrence versus cost is being calculated. So we also take the impact of the critical equipment and non-critical equipment to assess this cost. So hence it is a tailor-made thing which we can help you out to understand the cost of failures. If you have anything at sites, we will definitely help you out. Our service people are available to sort this out. Hope that answers your question.
Thanks for that, Suresh. We have another question again, which will go to you, Suresh. Can you let us know how fast the BTG teams can go to a mill in case of an issue with an instrument?
Thank you, Estelle. Indeed, this is what BTG is doing around globally because we are a very customer-focused company. We do have ground people who does the service support in each countries, and specifically in our ASPAC regions, we do attend these calls online, or we can help you to support remotely. We do have a module called BConnect. Now we have developed to get this done remotely with all the instruments being connected. With our expertise in Sweden, we can help you to connect this remotely. In case if the BConnect is not available at site, then we attend to that site maximum of 72 hours at the minimum of 48 hours is our time to attend that site. And most probably 90% of the problem we resolve it, unless otherwise it's a breakdown over online support or remote support. Thank you.
Thank you, Suresh. With that, we have now covered the question that we had in the pipeline. Of course, we remain available in case you have anything which would not have been discussed. You can connect your BTG local contact, or you can also connect us with the email through which you receive the invitation to this webinar. The video will be sent out as well as the slides that you have just seen. I thank again our presenter, and I wish everyone a very nice rest of your day. Thank you.